Another topic area that you've covered at Meta, which I guess kind of sits across all of these different topic areas because privacy is something that concerns every possible area. And I imagine this is something particularly with Meta dealing with so much personal data, privacy's got to be top of mind. You've been involved, you're part of the team that developed the CrypTen, CrypTen, the CrypTen privacy preserving machine learning framework. So what's this project all about?
So CrypTen, you can think about it as basically PyTorch. So like as a developer, like what you would write is essentially PyTorch code, and sort of like the goal that we were trying to get to and got really, really close to is that you can take your PyTorch code and you can replace import torch by import CrypTen as torch. And your code just runs.
Really?
Except the computations that you're performing are performed on encrypted data. So like your whole like neural network training is happening on data that you don't really understand, and sort of the weights you don't really understand either. And sort of what's implemented under the hood is a set of techniques called secure multi-party computation. And sort of the basic idea is that it enables like two different parties, for example, you and me, to like together perform computations on data that we don't understand. So like the key principles of those approaches are pretty easy to understand. So let's say you have some data, like let's say the number 12, and you want to do computations on that data with me, but you want to keep your data private. So you don't want to tell me about the 12 that you have.
I certainly wouldn't.
No, don't want to know about the 12, right? So what you do is you draw a random number, let's say 7, and you give the 7 to me. So now I have a random number, I don't understand anything. And what you do is you compute 12 minus 7, so now you have 5. So now together we have a representation of the 12, but I don't know that the underlying number is 12, and actually you don't know it either, right? Like if you had sort of thrown away the 12.
Yeah.
So why is this an interesting representation? Well, it's an interesting representation because you can still do computations on it. So for example, if we wanted to multiply your 12 by 2, I can multiply my 7 by 2, you multiply your 5 by 2, and together we have a representation of 24, right? If we had two of these numbers that are secret shared, is sort of the term that's used to describe this way of sharing data. If we had two of these numbers, what I could do, so let's say you had another number, 6, and I got 3 and you got 3, and we want to add this 6 and 12. Well, I can add my 5 and my 7 and the 3, and you can add your 5 and the 3. So now I have 10, you have 8, and together we have 18, right? So we have the sum of 12 and 6, right? So we can perform addition as well, and we can even multiply these kinds of secret shared numbers. The protocol to do that is a little bit more involved, so I'm not going to explain it in full detail, but you can do that as well, right? So now what do we have? We have a representation of numbers that, both of us don't understand the underlying data, but we can do addition and we can do multiplication. And really, that's all you need, right? So like from there,
for sure.
Well, I mean, you need other functions, right? Because you need to be able to compute values, and you need to be able to do normalization and so on. But essentially, you can build all of those up from addition and multiplication, sort of in the same way that CPUs do that, right? Using all sorts of approximations, or by doing the multiplication and addition sort of at the binary level, which enables you to implement things like, sort of logical operators, which you need in order to do comparisons and so on. And so what CrypTen is implementing is basically all of that. It sort of like is implementing these like super primitive operations. And then on top of that, it enables you to evaluate all the functions that you need in order to do deep learning. And then on top of that, it builds autograds, sort of in the same way that you expect from PyTorch. And then on top of that, it implements like a full neural network library that uses the same API as PyTorch. And what's cool is that sort of in this lowest level of implementation, it is actually calling into PyTorch again, which means that we can do these computations on GPUs as well to do acceleration. And so really what sort of this whole framework is enabling us to do is it enables us to do deep learning on that 12 of yours and that whole bunch of like other numbers that you don't want to share with me. But together we can still sort of get the value out of that data, in particular out of the union sort of the data that we have.
Very cool. So I guess it would allow different counterparties to even collaborate together. So you could have two corporate entities that maybe two pharmaceutical firms that want to be able to pool together research that they've conducted separately, but they want to keep the research proprietary to the individual organizations. They could pool their data together and train a neural network model, do inference with that neural network model, even on GPUs, without ever having to share the data with each other.
That's right. That's right. And all of this is like cryptographically secure, so they're very like very strong sort of theorems like to sort of prove that this is actually secure and that I will never be able to learn something about your 12. Yeah.
Yeah, very nice. And is there any impact on like computational efficiency?
Yeah, so I mean, this is definitely a lot slower,
okay,
right?
Okay.
Like that is the sort of big price that
Yeah.
you pay. And so we are able to do sort of like modern neural networks, but we wouldn't be able to train a model like Llama 2 in this way. Typically, like the computational overhead is in the order of like 100x, right?
Oh,
so
wow.
like,
Yeah,
so,
wow.
so it's quite substantial, despite sort of all the optimizations that we did. And that is mostly because the protocols that we're using, in particular the private multiplication protocol, similarly we use that in things like convolution or in attention mechanisms and so on. Those are quite sort of computationally intensive.
Right.
And more importantly, they require us to communicate. Like we are going to
Right.
communicate intermediate results, and that communication takes time.
Yeah. It makes perfect sense. It would have been wild if you told me, I guess now in retrospect, having asked my question, if you'd said, yeah, it runs
It's just as fast. Yeah, that would be amazing. I mean, then everybody would be using it for like every possible use case, right?
Yeah.
So that is, I think, not quite feasible. But it is unlocking use cases like the one you just described, where the alternative is to not do the work at all, right? And so that is really sort of the baseline you're comparing with. Like you're not getting the value at all, or you're getting it and you pay a computational cost for it.
Very cool. And CrypTen is open source. So our listeners right now, they can pip install CrypTen and
That's
use
right.
it just like the PyTorch interface that they're used to for building and training and deploying deep learning models.
Yeah, for sure.
Super easy.